Hey guys, Mr. Milton here. Today we're going to talk about standard form again a little bit more. At the end of the video, you should be able to explain when to use each method in graphing lines, standard form versus slope-intercept form, and you should be able to write an equation in standard form from a word problem. Okay, so now we have two forms. We've actually talked about three forms. We talked briefly about point-slope form, but we have two forms that we can use very regularly here, and we are going to talk about when we should choose to use each one to graph. Okay, and here's the basic, the big picture is that when we get to use nice numbers, that is the form that we'll use. Okay, so it'll kind of depend on where it starts, and it'll depend on nice numbers. So for number one here, we're given this, and this starts out in standard form. Okay, and so that's what we'll look for first and say, can we graph in standard form using nice numbers? Okay, remember for standard form what we do is we find the x and y intercepts, and so we'll basically say, are these whole numbers? So when we find the x-intercept, we have 6x equals 12. So our x-intercept then will be at 2, and we have negative 3y equals 12. And so then our y-intercept will be at negative 4. Okay, so these are both nice numbers. So we have a point at 2, 0, and a point at 0, negative 4. We can plot those numbers without too much issue. 2, 0, our x-intercept, and 0, negative 1, 2, 3, 4, our y-intercept. And there's our line between those 2 points. Okay, so in a situation like that, I would choose to use the intercepts. Okay. Number 2, you can see this as well, and look and say, okay, x is 1, 2, 4. These are both, 4 is divisible, negative 4 is divisible by both coefficients here. So I should probably choose to graph using standard form. Again, because it starts in standard form. If we were given this in slope-intercept form, it's not like we want to change it to standard form in order to graph it. So here, when we get it by itself, x is negative 4. So there's our x-intercept at negative 4, 0. X. So then we have 2y equals negative 4 divided by 2, y equals negative 2. And so then we are at 0, negative 2. And so here are our points, negative 4, 0, 1, 2, 3, 4, negative 4, 0. That's our x-intercept, 0, negative 2. That's our y-intercept. Have a line that goes through both points here. And there we have it. Okay. And so again, want to see, do we get nice numbers? And if we don't, so if we look at number 3, we have 5x plus 2y equals 8. Now, I'm looking, 2 and 8, those are divisible, so 8 divided by 2 gives us a nice number, but 8 and 5 isn't. Okay, we would get a fraction if we tried to find the x-intercept here. Okay, and so what I see is I'm not going to be able to find the x-intercept. I can't use, well, I could find the x-intercept, but I get a fractional x-intercept, and I wouldn't be able to accurately graph that. So I'm not going to use a fraction as my x-intercept. I need to change this to slope-intercept form. So for this problem, I need to change to slope-intercept form by solving for y. So I'm going to subtract 5x from both sides here. Start getting y by itself. Then I'll get 2y equals negative 5x plus 8. Okay. And then I'm going to divide by 2 to get y all the way by itself. And then y will equal negative 5 over 2x plus 4. Okay, and you'll notice that, hey, we have a fraction. I thought you said we didn't want fractions. We don't want fractions as points. Fraction as a slope isn't really that bad because it's telling us go down 5 and go to the right 2. Okay, which we can do pretty easily and accurately. 1, 2, 3, 4. Our y-intercept's at 4. Then we go down 5 and over 2. And we could do that again. Go down 5, 1, 2, 3, 4, 5, and over 2. And so here we have our line. here and there. Okay. So now that line. And notice we changed this into slope-intercept form to graph. Okay. And number 4, we have 3x minus 9y equals 45. Try that out. Can we use standard form? Should we change the slope-intercept form? Give it a try, graph it, see what you get. So notice that each of the 4 lines is in standard form. Again, if we're given it in slope-intercept form, we probably want to graph it there. Okay. When in this form, we typically use the method to graph. Typically find the intercepts to graph. For which graphs was this method difficult? Okay. And the one that was difficult was number 3. That was the only one where we really had issues with that. Or number 4, let me know. And it was difficult, and you can write this down, I won't. It was difficult because we had fractional intercepts. And so in those cases, what should we do? Change the slope-intercept form. Okay. All right. Back side. Okay. Let's look at some more problems. So, Greg can make $10 per hour mowing lawns and $8 per hour working at McDonald's. Greg wants to make $200 so he can have some money, some spending money for the weekend. Write an equation to represent this situation. Let x equal the number of hours mowing lawns and y equal the number of hours working at McDonald's. Okay, so let's look at this. He wants to make $200, and we'll say he wants to make exactly $200 so that we're not looking at an inequality here. He wants to make exactly $200. And so I'm going to say that mowing lawns, I'm going to use X. And working at McDonald's, I'm going to use Y. Okay? And so, oh yeah, that's what it says down here too. So we can make $10 per hour mowing lawns, and we can make $8 an hour working at McDonald's, and we want that to equal 200. Okay, so what is the x-intercept? Okay, again, we can find the x-intercept by covering up y. We have 200 equals 10x, divide by 10 on both sides, and so that x will equal 20. What does that mean in this problem? Who is this? What's his name? Greg could work 20 hours. Mowing lawns, or mowing 20 lawns, I guess, to get $200. Okay. What is the y-intercept? Okay, we're going to cover up the x. 8y. That'll give us 25. Okay, 25. What does this mean? Greg could, and I'll just do work 25 hours at McDonald's, Mickey D's, okay, to make $200. Okay, all right, now D says it was a rainy week, so Greg was only able to mow lawns for 4 hours, because if he wants to use his time well, he should just mow lawns because he makes more money there. Okay, so Greg was only able to mow lawns for 4 hours. How many hours does he need to work at McDonald's to reach his goal? So now that we know he was able to mow lawns for 4 hours, then what we can do is in this equation, instead of saying 10x, x is no longer a variable. It's 4 plus 8y equals 200. So he made $40 this week by mowing lawns. And subtract 40 from both sides. I'm going to work up here now. So we have 8y equals 160. Divide by 8, and we get that y is 20. So now that he's worked those 4 hours at McDonald's, he would have 20 more hours to work at Mickey D's in order to make his $200. 5 says, after 5 hours in McDonald's, Greg was fed up and quit. How many hours of mowing lawns does he need to complete to reach his goal? So again, 10x, but now our y is not a variable. He could only make it 5 hours. That's all he had in him. Still wants a goal of $200, so 10x plus 40 equals 200. 10x, if I subtract 40 from both sides, will equal 160. Divide by 10, and x equals 16. So now he would have to mow lawns for 16 hours to make his money. Okay? Alright. One more problem here. Okay, in college I had a job where I had to load softener salt into people's cars. The salt bags came in 50 pounds and 80-pound bags. Okay. Customer one day asked for a ton of salt, like literally a ton, 2,000 pounds. Okay, write an equation to represent all the possible combinations of salt bags that this customer could receive. So here we go. We could give him 50-pound bags, 50x, 80-pound bags, 80y, and the combination of that should equal 2,000 pounds. Okay? And so, if we're going to graph the possible combinations here, then what we would do, we would be finding our our intercepts. So we have 50x equals 2,000, 80y equals 2,000, and we'll be finding the x and y intercepts. So 2,000 divided by 50, so x would give us 40. So our x-intercept would be at 40, 0. And then 2,000 divided by 80. So y would equal 25. 0, 25. Okay. So looking at this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm just going to say that each of these things is worth 5. Let's say they're all worth 5. Okay. So everything's worth 5. 5, 10, 15, 20, 25, 30, 35, 40. So my x will be here at 40. I'll do the same thing here with 5. 5, 10, 15, 20, 25 here. Okay. So this would be the y's, and that is the 80-pound bags. And this would be the x's, which would be the 50-pound bags. Okay, and then I have my line that contains these 2 points. Okay, sure, I can get rid of this calculator now. Alright. So this customer said that when he unloads the salt, he wants to make as few trips as possible from his truck to his softener in the basement. Assuming he carries 1 bag at a time, which combination would best suit the customer? So if he wants to make as few trips as possible, that means he wants the heaviest bags. And so the fewest trips possible would mean that he would want 25 80-pound bags. 25 80-pound bags. And 0 50-pound bags. That would be the best combination for him. Okay. As I was loading the truck, I realized that I was going to run out of 80-pound bags before he received this ton of salt. I ran out of 80-pound bags after giving him 15. How many 50-pound bags do I need to give the customer to meet his order? That is what I want you guys to find out and bring to class with these completed notes. Okay, so now you should know how to choose between slope-intercept form and standard form and graphing, and also how to write an equation from a situation in standard form. Alright, finish this problem, and I'll see you